previous class, we learnt about units, tens, and hundred, that is, three digit numbers. In this chapter, we learn about thousands and 10,000s. Now, we will learn about four digit numbers. When we add 1 to the largest three digit number, that is 999, we get 1000. Here, there's a simple way of writing, that is, which digit comes in which place, the value of that place. This is how we write the figures in its place, which is also a good way to find out the place of the value. This way, it becomes easier for you to convert figures to words and words to figures. Numbers in words and figures. Now, there are two examples given here in figures which we have to convert into. The question is in words and we have to convert it into figures. Write 4 in the thousands place. Now we must write the digit in the thousands, hundreds, tens, and units place too. The given number has no hundreds, so we write a 0 in the hundreds place. 28 has 2 tens and 8 units, so we write 2 in the tens place and 8 in the units place. Here we are learning how to convert words into figures. Now in this first question, 4028, we have thousands as 4, 2 in tens place and 8 in units place. The given number has no hundreds. Here in this question where we observe that when it's read, it's said as 4028. Now 1000 is here. 28 means 2 comes in the tens place and 8 comes in the units place, but there is no 100. So at this point we have to write 0 in the hundreds place. Figure becomes 4028, that is 4028. Whenever you get a question where you find a place missing from thousands, hundreds, tens, or units place, then you are required to add a 0. Second question, 5309. In this number, there is a 5 in the thousands place and 3 in the hundreds place. There are no tens, so we write 0 in the tens place. We write 9 in the units place. In this question, 5 is in the thousands place, because the question only says 5309. So we know 5 is in the thousands place, 3 is in the hundreds place, and 9 is in the units place. But we don't know about tens. There's no tens given in this question, so we write 0 in the tens place. Hence the figure is written as 5309. Easy to understand? Now we get to learn about 5-digit numbers. Here again I am showing you this table. Largest 4-digit number was 9999 plus 1, that became smallest 5-digit number, which is 10,000. Now when we add 1 to the biggest 4-digit number, that is 9999, we get 10,000. 10,000 is read to the left of thousands. After 1000, now we are learning about 10,000, that is 5-digit numbers. Here are few figures, as for example, the 10,000, how it is written: 20,000, 68,000, 79,000, 80,000. Now 20,000 has 20 in the tens place. 68 has 60 in the tens place and 8 is the thousand. 79 again has 70 in the 10,000s place and 9 in the thousands place. 80,000 is 88 is in the 10,000s place. Numbers in words and figures. first one, 62,037. Here 62,000 is equal to 60,000 plus 2,000. It means that here we have 6 10,000s and 2,000s. This number has no hundreds, so we write 0 in hundreds place. Now previously when we learnt about the two examples in 4-digit numbers, we added 0 into the empty places. When they have not given a place value, we simply add 0 to the digit. Now same way, here we are learning about numbers in words and figures of 5-digit numbers. This figure 62,037, earlier when we learnt about thousands, that is 4-digit number, we saw that we had to add zeros when the value missing. So now in this figure we have 6 in 10,000s place, that is 60 in the 10,000s place, 2 in the thousands place, 3 in tens place and 7 in units place. The given number has no hundreds, same as it is like the 4-digit numbers examples. So simply we add 0 to the hundreds place. Second example, 70,206. 70,000 is 7 10,000s. There are no more thousands in this number. There are no tens either, so we write 0 in the thousands and tens place. Now here 70 is 7 10,000s, 2 is 100 and 6 is units. In this figure we have no thousands and no tens place, so we write 0 in the thousands and tens place. Third example, 30,001. Here 30,000 is 3 10,000s. Besides these, there are no thousands or hundreds or tens in this number, so we write 0 in those places. 30 is 3 in 10,000s and 1 is units. In this figure we do not have thousands and also we don't have 100 and tens, so we write 0 in those places. Now we are going to learn the next topic, that is expanded form. In this earlier classes, we have learned how to write the expanded form of 3-digit numbers. Now we learn about 4 digits and 5-digit numbers the same way. It is the same way how we used to add hundreds plus tens plus units. Now when we are learning about thousands and 10,000s, it is the same. We just have to add 10,000s plus thousands plus hundreds plus tens plus units. Now here's an example, 5,324. This is the 4-digit numbers, which means 5 in the thousands place, 3 in hundreds place, 2 in tens place and 4 in the units place, which means that the expanded form of 5,324 is 5,000 plus 300 plus 20 plus 40. Now 5-digit number example, 23,375 means 2 in the 10,000s place, 3 in the thousands place, 3 in hundreds place, 7 in tens place and 5 in units place. The expanded form is 20,000 plus 3,000 plus 300 plus 70 plus 5. It is easy to understand, just expand the figures. If there's an example given here with a 0 in that digit, like I'm giving you an example of 20,085. So when we get 25,085, we have to figure out the place first, like the earlier two examples. So 2 comes in the 10,000s place, 0 is in the thousands place, 0 is in the hundreds place, 8 is in the tens place, 5 is in the units place. So the expanded form will be 20,000 plus 4 zeros, that is the thousands place, plus 3 zeros, that is from the hundreds place, plus 80 plus 5. You can also write it as 20,000 plus 80 plus 5. The figure would come in the same place as the place value. This is a shorter form, but when you add the zeros, you know exactly how the figure would form. Now we learn the important part, and also the part where most students find it difficult: finding the place value of the underlined digit. Here we have 1999. The third digit is underlined, which means you have to write the place value of the number, which is tens. If you count from the right side of the figure, the second figure is underlined. The place value of each number given in the digit. When you simply count from the right side of the number, you can easily figure out the place value of each number given in the digit. Like I said, just counting or reading out the figure, you would actually understand where the place stands. So the underlined digit, finding what the place of the underlined digit is, would become easier for you. When we learn about the different breakups of a number, this is the same as to how we break the digits and its place value. Now this topic, the different breakups of the numbers, this is the next topic. This is same as finding out the underlying digits place value. For that, I would like to share this a short dialogue form example for the place value topic. Tai, let's play a game. I'll say a number, you give the expanded form of that number. Your number is 55,555. Dhruv, 50,000 plus 5,000 plus 500 plus 50 plus 5. Priyanka, that's funny. There's 5 in every place in the number, but its value is different in each place. The place of a digit determines the value of the digit. Tell me the place value of each of the digits in the number 37,842. Dhruv, let me tell. 3 is 3 10,000s, which is 30,000. 7,000 is 7,000. 8 is 800. 4 is 40. 2 is 2 units. Now here first we are given a 55,555. 50,000 plus 5,000 plus 500 plus 50 plus 55. Now here each place carries a different place value. Value of the digits are different. So here they are telling us that the place value of each digits are different, even if the digits are same. Here, even the second example, 37,842, they have just given it as a number. Dhruv, guess the place value of each numbers. So this is how you learn properly, when you know the place value of each numbers. So the different breakups of a number was also the different breakups of a number means that we have to find out the breakups of each numbers, that is place value of each number. The number comes under what value, that is hundreds or tens or units or even thousands. You just have to figure out the names of the number. So Reading out the number or substituting the numbers into those values would or the into those places would help you figure out the places of the value. We have before and after numbers, which we have been learning since our early classes. If we are given 121 as a number and you have asked the before number of 121, then you know that it is 120 because you know serial numbers since you're studying serial numbers since school. So this simple before and after number. Then we have comparing numbers. Comparing numbers are where you will be given few numbers from which you have to identify which is smaller or bigger. Com- Here we have comparing numbers. Tai, what do you remember about comparing numbers? Nandu, any three-digit number is bigger than any two-digit number. Priya, and if both numbers have three-digit numbers and the one with the bigger 100-digit number is the bigger number. Tai, so now how will we compare numbers having up to 4 digits? Priya, any three-digit number will be smaller than any four-digit number. Here they are talking about the 4 digit and 3 digit numbers. When you are asked to compare against the 3 digit numbers, you were comparing it as 3 digits and two digit numbers. Now when we are talking about 4 digit number, you are comparing with the 3 digit numbers. So Nandu says, if both numbers have 4 digit number, the number with the bigger 1000 digits will be bigger number. If the 1000 digits are equal, we'll compare the 100 digits. If those are also equal, look at the 10 digits to determine the smaller and bigger numbers. For example, here they are given 4567 and 4325. Here the first place, that is 1000, is 4. Both the figures are having 4 in its place. When the bigger thousands are equal, we'll go to the next number, that is hundreds, and we have 5 in the first digit and 3 in the second figure. So 5 is bigger than 3, hence 4567 is bigger than 4325. This is how comparing numbers are done. Then we have ascending and descending order, which is also the same thing which you have been learning since first standard. When you know the place value of the digit thoroughly, you will know the difference. Just reading out the figures would make you realize what the answer should be. Here we have given cupboards of several digit companies are on sale in a shop. The price of one is 4,750, while that of another is 3,200 and third 3,980. The price of the costlier cupboard is 6,200. Now the biggest price from all these three prices was 6,200. The price of the cheapest cupboard was 3,980. The lower price is 3,980. So the prices in ascending order would be, ascending order is the order which you write from the smaller to the bigger digits, that is 3,980, then 4,750, and then 6,200. The prices in descending order would be the opposite of that, that is bigger from smaller, which is 6,200, then 4,750, then 3,980. This is how you write ascending and descending order. Now, even and order, even that is also the same topic as to which we have been learning from our previous classes. Before and after, comparing numbers ascending order and descending order, even and odd, are all for you to understand the place value of each digits very carefully. If you want a explanation of even and odd, it goes like even is simply when teachers used to teach, they used to tell us to remember the twos table, which has the even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, like that. That was the even numbers, and the odds would be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. These are odd numbers. Now, when you get a bunch of figures as a question for even and odd number, which could be 2 digit number, 3 digit number, 4 digit number, 5 digit number, because this topic is all about till 5 digit numbers, so you might get even to that extent. So you just have to figure out which is the even number. If to the end of the figure you have a digit from the twos table, then is the even number. Other has the digits other than the twos tables, that is from 1, 3, 5, 7, 9, like that, then it is an odd number. Then you have to put it in the odd numbers. This is how you simply do it. If you have a doubt, in the end I'll give you some questions, solve them. This topic is also easy. Now they are telling us about international numbers. Here, Suresh, hey Vijaya, when you have you noticed all the numbers printed on our currency notes are in English? Vijaya, yes, that's true. What did you think they would be? Suresh, well, I thought in Maharashtra they would be in Marathi. Come, let's ask Tai about this. Tai, why are all the numbers printed on our currency notes in English and not in Marathi? Vijaya, as mostly all the numbers on our vehicles too. Tai, very good. Excellent observation. Now tell me, how any of you traveled outside the Maharashtra? Vijaya, yes, Tai, we have been to Karnataka. Tai, could you read the names of shops on their signboards? Vijaya, no, I couldn't. Tai, that's because they write letters using a different script. Their numerals are also different from ours. Suresh, how do they write them? Tai, in Marathi we write 1, 2, 3. If we had 1, 2, 3 on our currency notes, how would they read them? Vijaya, and if the numerals were like theirs, we wouldn't be able to read them. Tai, that's right. It means that the numbers on currency notes should be each that everyone in India can read them. And not only Indians, but visitors from other countries should also be able to read them. Suresh, yes, I agree. Because if I had to go to another country, I would like to be able to read the numbers on their notes. Tai, well said. That's why all the countries of the world have agreed that numbers to tell the value of currency notes or their serial numbers should all be printed in English. So also other numbers such as the serial number of train tickets of buses and airline tickets. Vijaya, now I understand that must be a reason why overall our country too buses and autos numbers are written in English. Tai, when numbers are written using English numerals, everyone in world can understand them. That is why these numerals are also known as international numerals. You are already familiar with them. This conversation is all about why English numerals is mostly used everywhere. Now, this conversation itself is explanatory because they're telling us if we go outside India or outside Maharashtra, you'll get figures in their languages which we wouldn't know. If you're traveling outside India, there are figures or language we wouldn't know. And English is a language which everyone prefers to learn or read. So all the currencies are printed in English. All the numbers and serial ranks are mostly written in English. So people would be able to understand, read, and write. So why these numerals are now called international numerals. We all are familiar with these numerals. Here we are given two tables: Devanagari numerals, international numerals. In first table 0 to 9, and the second table they have given few 3-digit numbers. And below that, reading numbers and writing them in words which are all in English. These are simply examples for you to know better. This chapter was really easy. This chapter is just covering the 10,000s and 10,000s topic. We learned how to convert in figures and words, the expanded form, how we figure out the underlined digit, place value, then comparing numbers, bigger and smaller, before and after, ascending order and descending, even and order, and now international numbers. If you have any doubt, just put your doubts in the comment section and solve these problem sets which I am giving you. Just practice at home. I'm sure you'll learn better and know everything from these questions.